I don't remember, but let's put, but for those people who know me, it's not, I mean, things like this happen, yes. So it's not something that I'll say, no way. But I don't remember, yes. As I said, in fact, about a month ago or so on, I was at a memorial for somebody and so on, and as I was speaking, suddenly I made a comment that everybody says that memory gets worse with age. And I said, no way. Memory gets much better with age. Because our memory shrinks so much that retrieving is immediate. Whatever you remember. All the rest, don't bother. So memory improves with age. I mean, what I remember very well. So sorry, I don't remember this. Okay. I'm not sure the cognitive people will agree with me, but anyway. Okay, so thank you for inviting me. I mean, law and economics. Okay, I hope that the topic will have some bearing to things that you care about. Let me say that this is joint work, so I'm going to talk about a piece of work a few years old. I'm sorry, I didn't do anything related to law and economics last year, so I have to go back a couple of years. So Ilan Kremer and Moti Perry, two of my colleagues, and there is a published paper in EALE, and there is an unpublished paper that you can find something on my webpage, and everything is on my webpage, including this presentation. Okay, so if you care about it, you can look at it. Okay, so what's the problem? Okay, so here's a standard question, yes? The employer goes to the worker, I mean, you deserve a pay raise. What would the worker say? Of course. Okay? That's economics. Now law. Are you guilty and deserve punishment? No, of course I'm not guilty. Right? Okay, so you ask people, that's the answer you'll get. Okay? So the question is, how can one obtain reliable information? Because everybody will say, I want the highest possible salary, I'm the best, of course I should get the highest salary. Everybody will say, I'm not guilty, you know, it's the other guy, it's not me, so I shouldn't be punished, okay? So how can one obtain reliable information in situations of this type, and I'll explain what I'm talking about, and more to the point, or moreover, how does one determine the right reward, the right salary? So we are not talking about Israeli universities where it's fixed, but places where you bargain with the deal, okay? Or other countries where it's, or how does one determine the right punishment, okay? So now, what really one wants is to be able to separate between the good and the bad, between the guilty and the innocent, okay? That's the kind of thing that we want. And of course, I hope that people here are aware about the unraveling phenomenon, starting with Akerlof, famous paper on the lemon market, the car. Okay, so there is an issue. Okay, there is a big issue here. How do you get reliable information? How do you separate between the good and the bad? Okay, so let me tell you what the general setup. The general setup is very simple. It's extremely simple. Okay, there are two players. Okay, there is one which is called an agent, and one which is called the principal. Okay, so it's a principal-agent model. If you know what I'm talking about. So the agent has information. The principal has no information, but he's the one that makes the decision. Okay? So think about the agent is the worker. He knows how good he is. The principal is the employer that has to decide how much salary to give, and he doesn't know. Okay? Or he's the judge, or the jury, whatever. Okay? Now, what happens? There is some communication that's going on. So the agent transmits some information to the principal. And we are in a setup where the transmission of information is costless, okay? Cheap talk, okay? There is no, it doesn't cost you, so that's very different. I'll talk about this again, but that's very different from the classical signaling models, for example, where different signals have different costs. That means that signals cost you something, okay? Here, signals have no cost. So it sounds as if, okay, so no cost, I can say everything, problems not solved. Okay, yes? Let's go on. No, we can say something, so let's see. So we're talking about two setups, and let me immediately say what those two setups are. Setup 1 and setup 2, let's call them. Setup 1 is this. The agent sends some messages, okay, to the principal, and then the principal decides, yes? So I tell the dean, you know, I'm very good and so on, whatever and so on, and then the dean decides how much money, what's my salary going to be, okay? The other is ahead of time, the principal decides on a policy. Okay, and says, if you send me this message, you'll be paid that much. If you send me that message, I'll pay you that much, and so on. And so a policy is a function that assigns a decision by the principal to every message that the agent might send. And the agent, of course, knows what this policy is ahead of time before he sends the message. And what's crucial is that the principal is committed to this policy. So you cannot say, if you tell me that, I'll pay you so much, then you tell him, say, no, you are going to be paid something else, because that's not going to work. So commitment here is crucial for this to work. Now those two setups, in fact, it's what we'll call, the first one is a game, the other is a mechanism, what's called the mechanism design setup. So we'll talk about the game and the mechanism. Okay, so remember the difference is the game, agent sends message, then so first agent plays, then the principal plays. In the mechanism, the principal ahead of time commits to a mechanism, commits to a policy, and then the agent sends a message, and then the rewards are being paid. Okay, now let me tell you immediately the main result, okay? Which, I don't know if it's going to be surprising or not, but we'll see. We'll have some examples shortly, and, but now I'm at a very high level talking. I mean looking from high above doesn't mean high in some other senses, yes. Sorry. So that's the main result. Okay, so in evidence games, which is a class of setups that I'm going to define, we are comparing the equilibrium outcome that we get in the game when there is no commitment. Okay? And we are looking at the optimal mechanism outcome in the mechanism setup where the principal can commit. Okay? In evidence games, those things are the same. They coincide. Okay? Now, I can of course make this theorem correct by just defining evidence game appropriately, yes? You know, just find one game where this is true, and of course there are degenerate things, but the whole idea is that evidence games are going to be a huge class of interesting setups, including for law and economics, or perhaps in particular for law and economics, yes? We'll have examples of both. Okay, so we have this equivalence between those two things. And now what are evidence games? So evidence games, again, roughly speaking, the agent has some pieces of evidence regarding his value. So if you are talking about the professor who wants to get a raise in his salary from the dean, I mean he has, for example, a letter of acceptance from Econometrica or from the law review, whatever, or maybe he has a letter of rejection from those, yes? He has some pieces of evidence, or maybe he has an outside offer, yes? Now, he can show those things, or maybe not, okay? So here are some pieces of evidence, okay? He knows exactly what this evidence is, he has them. They are in his possession. The principal doesn't know what evidence he has, of course. Okay? Principal decides on the reward, we already said that. Now, what's the aim of the principal? So the principal would like to give the right reward. So in the legal setup, the punishment should fit the crime, yes? In the economic setup, we want to pay the right amount, yes? I mean, the dean wants to pay the right salary. He doesn't want to pay too much. I mean, he has a budget constraint, remember, he's a dean, yes? I don't know if there's any dean here, or ex-dean, yes, there is one, yes. You have a budget constraint, so you can't pay as much as you'd like. You'd like to pay to everybody, but they don't give you that. On the other hand, you don't want to pay too, do not want to pay too little, because then the guy is going to leave and go elsewhere, right? So we want to pay the right amount. Okay, now, what about the agent? The agent wants the reward to be as high as possible, regardless of what evidence he has, regardless of what. He wants the highest possible salary that he can get, right? He wants the lightest possible punishment that he can get. That's what he wants, regardless of his time. And that's exactly, oh, I see that the bottom line is missing here. Okay, yes, that's, is there any way to adjust this, or that's it? Okay.
We can see it.
Hmm?
We can see it.
Yes, okay. So, that's very crucial. The fact that all types, regardless of what kind of agent you are, whether a good worker or bad worker, whether you're guilty or innocent, your preference is identical. Namely, what the highest reward, the minimum punishment, okay? And that's very different from all the standard information economics models, like signaling, there is a cost for signaling, or screening, or chip-top models, where, again, the payoff depends on type and so on. So the payoff of the agent is type independent. That's crucial. And again, you think about the examples I give, that's exactly what happens there. Everybody wants the same. So how do you distinguish? If people want different things, then you can separate. That's exactly what all the signaling and screening models are about. People that have different preferences, you find the right thing that separates them, yes? But here they all want the same, how do you separate? Okay, so now there is truth, okay? Truth is here, remember there is evidence, there is truth. So the agent reveals the truth, nothing but the truth. So what it says is that evidence that is revealed is verifiable, okay? You cannot fabricate a letter, okay? Because it's going to be checked, okay? But you don't have to reveal everything. You don't have to reveal the whole truth, okay? So all the evidence must be true, but you don't have to reveal everything. And that's where the whole game is. That's where the interesting thing is, okay? So that reminds me, the judge that went to the dentist, and just as he was on the seat, the dentist came with a zzz, said, wait a minute, please raise your right hand and repeat after me. I shall extract the tooth, the whole tooth, nothing but the tooth. Sorry. Once in a while. Okay, so that's crucial. What you reveal must be true. But you don't have to reveal everything, people don't know, yes? You have a rejection letter, you don't have to reveal it, right? I mean, anybody seen CV that includes rejection letters? No, right? Okay. Once in a while, yes, but that's when you really want to make a certain point. There are cases when you want, yes. After you got the Nobel Prize, yes, look at this rejection letter. Yes, that's exposed, not when it mattered. I'm sure that you didn't show that letter when it mattered for your promotion. Okay, so that's truth. Now, there is here now truth has a certain prominence, okay? Which I'm going to refer to this as truth leaning, and that says that revealing the truth we give to it a slight boost. That's going to be important, I'll tell you later where. And again, when lying or not revealing the whole truth is difficult, because you have to remember, yes, I think Mark Twain said something like this, yes? You have to remember what exactly you revealed and to be consistent, yes? Revealing the truth, just have to remember the truth, that's it, and that's very simple, okay? Something of previous work, okay, let me not talk about that, but later, there's Glaser and Rubinstein here for maybe this can go down further, or that's it, okay, never mind. There is any button that... Okay, so it's okay. I think the bottom line is probably going to be very few slides. I'm trying to have slides with no more than 6 lines per slide. That's a good rule. But, okay, so let me tell you what evidence games are. I mean, I already gave you some general setup. So what I'm saying is that they model very common setups. Okay. Thank you. Okay, so what I'm going to, here's a what we call executive summary of the paper. Yes, I'm giving it to you now. You can leave if you want. So first of all, I'm going to claim that evidence games they model very common and important setup, in particular in economics and in law, and we'll talk about those. We are going to see equivalence between what happens with commitment and without, and we are going to, also we are going to claim that the class of games that we define and the class of conditions we put are exactly the right ones for this equivalence to hold. Once you go beyond it, there is no longer equivalence. So that really defines the universe where this happens. Okay? So let's start with a simple example. In fact, 2 examples I want to show you. Very simple, but just to get the idea of what's going on. So let's talk about something close to our heart. Professor wants a salary as high as possible, and there is a dean that wants the salary to be as close as possible to the value of the professor, whatever that means. Let's suppose we can measure that in some sense. And the professor has some evidence, okay? And there are 3 possibilities, okay? With probability 50%, he has no evidence. With probability 25%, he has some positive evidence, an acceptance letter from some important journal. It's probability 25%, he has some negative evidence, a rejection letter from the same journal or from another journal. Okay? So those are the three types of agent, of professor. And let's assume that from the point of view of the dean, the value of a professor with the positive evidence is $90,000 or 90 Bitcoin, whatever, something, some unit. Okay, we don't care. Nothing depends on the numbers, but just I like them to be round numbers. That's all. You know, it's not a voting poll station someplace where round numbers are not the right thing. Some people know what I'm talking about, right? Yes. There was a polling station where all the results were 20%, 30%, 10%, you know. Random results. Okay. So I put that over there. So the three types, I'm going to call them T plus for the positive evidence, T0 no evidence, T minus negative evidence. Those are the probabilities and those are the value to the principal, to the dean. So the dean, if you knew exactly what type of professor this guy is, he would pay 90 to T plus, 60 to T0, and 30 to T minus. Okay? Very good. So let's talk first about the equilibrium. Remember what the equilibrium is. Again, the professor provides evidence, so he can bring a letter, or bring nothing, yes? I mean, you prepare the file, you can include a letter or not, okay? And then the dean sets up the summary, okay? So what's the equilibrium here? So clearly, now remember, the professor wants the highest possible salary, okay? No matter whether you are good or bad, no matter what your type is, you want the highest possible salary. So clearly, T plus, with positive evidence, provides it, and will get 90, the best possible, right? Okay? What about T0? Okay? T0 cannot provide any evidence, so that's it. What about T minus? Is he going to provide the evidence? No, because if he provides the evidence, he will get 30. If he does not provide the evidence, what is he going to get? Not 60. I hope that you realize. No, not 60, because now the dean is not stupid. Okay? The dean says, wait a minute, I got no evidence. I got no evidence. It's either from the guy who really has no evidence or from the guy that had negative evidence and didn't show me that. So what's the expected value of such a professor? Well, okay, what's the expected value? It's 50. Why? Because it's twice, because remember, this is 50%, this is 25%. So without using Bayes' rule, it's twice as likely to be the no evidence guy than the negative evidence guy. And the average of 60 and 30, where you put 2 thirds on 60 and 1 third on 30, is 50. Okay? That's a very complex computation, written on the bottom line. Okay? Yes? Is that, yes? Okay, down at 50. I mean, it's clear he's going to pay something between 30 and 50. That is the expectation. Okay, very good. That turns out to be the unique sequential equilibrium for those that care about exactly what it is in this game. And we are done with equilibrium. Okay? Oh, here there is even a nice picture. So here we have the three types of professors. These are, sorry I'm doing it slowly, but I wanted to see what's going on. The values are 30, 60, and 90. And the partial truth goes this way. 30 can claim that he has no evidence, can claim that he's a 60 guy. The 90 can claim that he's a 60 guy, so that's a partial truth revelation. So arrows tell you what you can do. Okay? So the guy with 30, of course, can reveal that he's 30, but he can also not reveal his information and be like the 60 guy. Okay? And this is the equilibrium. T minus says T0, T0 says T0, T plus says T plus. Okay? And that's what the dean pays, 90 to this, 50 to this. And if, that's not going to happen in equilibrium, but if the guy will say T minus, will increase negative evidence, of course he will be paid 30. Okay? And that's the unique equilibrium, sequential equilibrium. Mechanism now. Let's see. What happens in the mechanism? Okay? So the dean commits to a salary policy. He says, you get me positive evidence, you get so much. You get me negative evidence, you get so much. You give me no evidence, you get so much. That's it. I'm committed to it. Okay? And then the professor decides what evidence to provide. Okay? And of course, he wants, the dean is the one that decides on the mechanism, and he wants the mechanism to be such that at the end of the game, the salary would be as close as possible to the value of the professor. Okay? So it turns out that the optimal mechanism, I'll explain to you why, is the following. If you give positive evidence, of course, you get 90. You commits ahead of time, you give me positive evidence, you get 90. I mean, in fact, it's clear that positive evidence here reveals and gets 90. It's really outside the game. The whole game is between negative evidence and no evidence. Okay? No evidence, he says I'm going to pay 50. And if you give me negative evidence, some number less than 50. And he commits to that. Okay? Now, let's see why. So that's my claim. Okay? You see, it's exactly the same thing. Okay? Now, it may sound like a triviality. Let's see why it's not exactly the explanation. So what happens in equilibrium? Now, T minus says T0. The guy with the negative evidence says I have no evidence. Or doesn't say I have no evidence, he doesn't want to cheat, he just doesn't provide evidence. Okay? He just hides the letter, you know. Hope maybe the revision will work or something, who knows? Maybe another submission. Okay? So T minus says T0. Now notice, the value of T0 is higher than the value of T minus. T0 is 60, T minus is 30. Okay? That's crucial. What happens in mechanism? Suppose that what would be better for the dean than what we have? If you'd be able to separate between T0 and T minus. T plus is already out of the equation. T plus gets 90, everybody's happy, he's happy, the dean is happy, let's forget about it. Now it's T0 and T minus. What the dean would like to know, is this a guy with no evidence, or is he a guy that has negative evidence and doesn't show me the evidence? He would like to separate between them. How can he separate? Well, the only way to separate is to commit in advance to pay differently for no evidence than for negative evidence, right? Okay, so the only way to separate is to pay differently. Now, because the negative evidence can always not provide the evidence, to separate, he must pay for T minus for negative evidence more than he pays for no evidence. Because if he pays less for negative evidence, the guy with negative evidence will say, evidence? What are you talking about? Okay? I have nothing, yes? Okay? So the only way to separate is you have to pay differently to separate. If you pay less, you're not separating. You have to pay more. So the only way to separate is to pay to T minus more than to T0. I claim this can never be optimal. And here is a picture that will show you that. Okay? Oh, sorry. Okay? So let me, sorry, I thought I have it here, but I see I don't have. So think of it this way. This is a 30, this is a 60. Okay? To 30, you have to pay more than to the 60. So if I draw here the payments, 60 goes here, 30 goes here. Right? You must have single crossing, not single crossing, but not the single crossing I'm talking about, but this kind of crossing that the 30 goes higher. Now, can this be optimal? Remember, what you want this to be as close to 60 and this to be as close to 30 as possible. I claim this can never be optimal because move this to the left, move this towards 30, move this to 60, you are going to get better. From the point of view of the dean, you are going to pay something closer to the value. So this can never be optimal. And to be optimal, you are going to stop and you pay both of them the same. That's the idea, okay? And in fact, at the end of in the general model, that's roughly the general intuition of what lies behind it. That's why, even with commitment, you cannot separate. Anybody understood this? Yeah. Good. Okay. Example 2, I'm not going to show you. That has something to do again. For game theorists, it's important. That's to do the. So let me jump to example 3. Now, some people would say, wait a minute, I mean, what are you talking about? I mean, why would commitment matter at all? So the standard answer is, come on, man. We know that if you can commit, I mean, you can do much better, yes? If you are bargaining and you commit, you know, I'm not going to do so-and-so, yes? I mean, I'm not going to accept less than 80 out of 100, and you leave irrevocable power of attorney to your lawyer, that's it. I mean, and you go put in book 2 or something, that's it. Yes, you're committed. So commitment is very powerful. But why is it powerful here? Okay? I mean, we know that most setups commitment is a very powerful device, but perhaps here it's not. So here is an example. So essentially, it's a previous example. I got rid of the positive evidence guide, okay? Because anyways, it was just to show you that what you do with those, which everybody understands. And now I have the no evidence and the negative evidence, 60 and 30. Oh, the probabilities are 50% each. Again, nothing hinges on specific probabilities. Okay? So now the dean again wants the salary to be as close as possible to the professor's value. Professor, there is no evidence, wants as high a salary as possible, as before. But T minus doesn't want the highest possible. He's the weak guy, yes? And he wants the salary to be as close as possible to 50. Because he knows if he's going to get a high salary, that comes with lots of duties that he hates or whatever, I don't know what. Okay? So he really doesn't want to overshoot. His value is 30. He wants as close as possible to 50, but he doesn't want to get too much. Okay? There are people like this. Okay? Think of it even in a quadratic kind of distance that all the standard models talk about that. Okay? Let's see what happens now. So in equilibrium, can we have separation? Well, if we had separation, of course, then you will pay X is the reward that you give to type 0. So for no evidence, you pay 60. For negative evidence, you pay 30, which is their value. And in this case, so that's if there would be separation, that's how much you pay. But in that case, T minus is not going to reveal. Why? Because 60 for him, remember, he wants to be as close as possible to 50. 60 is 10 away from 50. 30 is 20 away from 50. So he prefers to get 60 rather than 30. So he's not going to reveal. So if there were separation, then there is no separation. We got a contradiction. So in equilibrium, there is no separation. If there is no separation, then it means that doesn't matter what you do, the dean is going to pay the average value, which is 45 in this case, 60, 30, average, 50, 50. Okay? So that's what happens in equilibrium. How about mechanism? Sorry, so that's equilibrium. Repeat, a mechanism. Here is an interesting mechanism. The dean commits to the following. You give me negative evidence, you get 30. You give me no evidence, you get 71. Why 71? It's 70 plus epsilon. Okay? Okay, you get 71. What happens now? Well, the guy with no evidence, provides no evidence, gets 71, which by the way makes him very happy because his worth is only 60, yes? He gets more than his value. What about the negative evidence guy? The negative evidence guy says, wait, if I give no evidence, I get 30, which is 20 away from my optimal point of 50. If I do not reveal, I'm going to get 71, which is 21 away from 50, further away. So I don't like that, okay? So T minus prefers 30 to 71, okay? And so he's indeed going to reveal his negative evidence and get 30, okay? Okay? Now, from the point of view of the dean, that's much better. Previously, he was paying 45 to everybody, which means he was 15 away. For each one of them, he made an error of 15. Now, he makes no error for T0, T minus, and he makes an error of 11 with probability 1/2, much, much better. So the dean is much happier. Okay? So now it's crucial that there is commitment, because if the negative evidence guy, because after no evidence, okay, because in this equilibrium, remember, the negative evidence guy gives negative evidence. The no evidence guy provides no evidence. The dean is committed that to no evidence he pays 71. If he can renege on this commitment, after no evidence says, wait a minute, I mean, I know that you are the 60 guy, I'm going to pay only 60. That's not going to work, because then again, we'll go back to the situation where the negative evidence guy will say, oh, but once you realize that, you change to, so you have to commit. The commitment must be a firm commitment where he cannot go back on that commitment. That's the only way this will work. Okay? So you see, a very small change in the example, we get a mechanism that is much better for the dean than the equilibrium. Okay? Very small change of the example, and what was the change? Okay? Look here. The change was here. The professor T minus wants the salary as close as possible to 50, rather than as high as possible as before. That's just this small change. That's what made the whole difference. Commitment matters a lot. Okay? So that's just to convince you that I'm not giving you an empty theorem, which is quite clear, but one has to be very, very clear about exactly what the boundaries are. Okay, so this is not an evidence game. Okay? Okay, very good. Summary, so there are 3 examples. First one showed you the equivalence. Second one I didn't show you, so ignore it. And the third one showed that without commitment, that if the assumptions of the model do not hold, then commitment can indeed help. Very good. Okay. I have 10 minutes. Let me very quickly say something about the model, just to show you there is nothing here special or fancy or anything. It's completely standard. Have an agent and a principle, finite set of types. Agent knows the type, but not the principal. Agent sends a message. Okay, I think I'm going to skip all this. Utilities again, message doesn't matter. Let me just go to the, okay, I'm sorry, I mean, I have 10 minutes because you wanted me to end 5 to...
No, to have some time for questions. So
yeah, okay, okay. So, forget all this. Okay, let's go back to the thing I already said about the truth, okay? About the messages, okay? What you reveal must be true, but you don't have to reveal everything, okay? So, what can the agent do? Agent can present a subset of the set of pieces of evidence that he has. Now, of course, what kind of subset? So, going to the dean and giving you referee report B only. Okay? So what will the dean say? Okay, give me the associate editor report and the referee A, but you give me only B, yes? You cannot do that, okay? That's a detectable deviation, right? So the only way to make an undetectable deviation is to pretend to be a type that has a different set of pieces of evidence, of course, which is a subset of what you have, because you cannot invent evidence, okay? Now, in fact, it turns out that this condition is not needed, one can do with it, but it's a very reasonable condition. So L of T is the set of types that T can pretend to be. So it's like a set of possible messages that T can be. So those are, okay, here is a setup that describes that. Let's not, okay, let me tell you what matters. I'm sorry, I'm doing it fast, but I want to get, what matters is that you can always tell the truth. So one possible type that you can pretend to be is yourself. You can always reveal all your information, okay? And the other is transitivity. If type T can pretend to be type S, and type S can pretend to be type R, then type T can pretend to be type R. Because pretending to be type S means type S has less evidence than you. And if S can pretend to be R, means R has less evidence than S. Now, having less evidence is transitive, so R has less evidence than T, and you can do that. That's the only thing that matters, okay? Okay, now, it's very important, a type of an agent has two characteristics. One is how much it is worth to the principal, okay? Like the 60, 90, 30. The other is what evidence you have. Now, we are assuming no connection between those things, okay? We're not assuming more evidence makes you better, because the evidence could be negative evidence, could be a rejection error. Okay? Because many models have this connection, more evidence is better. And then things become very trivial. Well, not very trivial, but sometimes things become quite easy. There is no relation assumed between value and evidence. Okay, now I'm going to jump, sorry. Okay. I'm guessing everybody knows how to write the game and what's an equilibrium, what's an optimal mechanism. So just to tell you the optimal result. The optimal result is the following. There is a unique truth-leading equilibrium. There is a unique optimal mechanism, outcome. We are not talking about strategies, but we're talking about payoffs that people get. That's what we really care. Doesn't really matter how this payoff was reached, but payoffs. We are not in payoff space. And those two are the same. That's the equivalence result. Okay, forget that. What's important that all the conditions that I mentioned, and those that I haven't mentioned, and I skipped over, all of them, okay, and here is the list, are indispensable. Anytime you drop one of these conditions, the result fails. There is no longer equivalence. So that's really the right universe where this holds. Okay? Okay, let's now talk about applications, okay? So, law and economics. Let's start with economics, then I'll talk about law. So, public firms. Disclosure by public firms, okay? Now, first of all, you are a CEO of a company, yes, and you reveal information. There are quarterly reports, there are investors' meetings, there are whatever. You reveal information, okay? If you lie, you go to prison, in principle, okay? So disclosing false information is a criminal act. Okay? That's a law part of economics. Okay? But withholding information is sometimes allowed. What do you mean allowed? It happens. Because, it's not clear when you got the information, and it's not clear if this contract has been already signed or it's a future thing. So am I going to reveal it in my report this quarter, or I'm going to move into the next quarter? I'm not lying. I'm not saying something wrong, but I'm omitting some information, okay? That's public disclosure. Now, by the way, public disclosure matters for the stock price a lot, and matters for the value of the stock options to the CEO even more, okay? So there are high incentives there for not providing the whole information, okay? And in fact, there are papers with real data that show, with actual data that show that this is a very prevalent phenomenon, okay? So without information, sometimes it is allowed, and it's very hard to prove that somebody withheld information, okay? Clearly impacts the asset prices. Now, what does our result translate into this setup? It says the following. If we look at so the CEO or the company manager, whoever, is the agent. He has the information. The market is the principal that determines the price of the company, the stock price. Okay, call it the market, yes? Okay? So the market is the principal and the agent is the CEO. So the market behavioral equilibrium, okay, is the best separation that you can get, even if you were to use mechanism and commitment. So commitments here ahead of time, like saying, look, if you are going to reveal this information, I'm going to give you some extra payment, or I'm going to do something, and so on, and you are committed in advance to that. So suppose the board, remember, there is a board which represents the stockholders, and there is a CEO. So the board may decide on a certain reward scheme, okay, commit in advance. If you reveal this information, you are going to get more money. You are not going to get more separation than what you get in equilibrium. It's not going to happen, okay? Now, there's a whole literature on disclosure, okay? In finance, in fact, some of it appears in accounting journals. Paper of Dye, D-Y-E, which is a very nice paper, except for his math was wrong, but the idea is correct. He didn't know how to compute conditional expectations. But other than that was correct. Okay? So they consider the equilibria there. They use, in fact, very fancy kind of ways to select the equilibrium that they want. I think there is even some paper where they have something called the sanitizing equilibrium. Okay? Turns out to be all special case of what we are doing here. Okay? In fact, it unifies everything that is done in this literature, which is quite huge, by the way. Okay, let's go to law. Okay? So think of constitution, laws, legal doctrine, all those are commitments. Those are commitments, right? If you have a law, that's a commitment that you are going to follow the law. Okay? So the system puts commitments in various ways. Okay? Now, of course, those things are going to affect the evidence that is provided in court. How the evidence is going to be treated, yes, precedents and legal doctrine and so on, they determine how the judge or the jury or whatever, whoever decides in court, is going to view this evidence. Okay? So clearly those commitments, the way evidence is treated, is going to influence which evidence is provided in court. Okay? That's clear. Okay? Now, here is a way to restate our result. Okay? Remember, equilibrium. Now we are talking about this truth-telling equilibrium that I didn't explain much, but it's a natural equilibrium in this setup. So what it says that all these commitments, the only thing they do is just select out of all equilibria this truth-telling equilibrium. Now truth-telling is, again, just to roughly speaking, is that equilibrium where everything else being equal, you'll tell the truth. That's essentially what it says. You give a slight boost to telling the truth. So let's look at the right to, here's an example. Let's look at the right to remain silent, okay? Which I guess here everybody knows. You have the right to remain silent. By the way, the UK is almost the same. So here is the right to remain silent in red, yes? In the US, you have the right to remain silent. In the UK, it's negative, yes? You do not have to say anything, yes? It's, you know the famous lecture in logic that somebody said, it's very interesting that double negative is a positive, but double positive is not a negative. Somebody in the back of the room, yeah. Okay, everybody knows. Okay, good. If you don't, I mean, it's a good one. Okay, but notice something else in the British law, okay? And if you see any of those UK series, you know, on TV or something, I mean, I found it by seeing that and said, wait a minute, that's exactly what it may harm your defense if you do not mention when questioned, which now, at the site of the crime, yes? It may harm your defense if you do not mention when questioned something which you later rely on in court. What is it? Just giving a slight boost to the truth. I mean, if you are going to reveal the truth later, it's going to be weighted less than if you do it now. So I want to encourage you to give a slight boost to the truth. Now, reveal it now, because now, you know, it's before you start strategizing and so on. So I take this blue thing as an instance of truth leading, an instance of giving a slight boost to the truth. And essentially, what we are saying is the following. So, okay, I'm finishing with this. So, equilibria clearly are going to entail inferences. From the fact that you provided some evidence and you have not provided something else, you infer things. That's what happens in equilibrium. But if you commit, so by our result, that's what's going to happen in the optimal mechanism. That's what you have to do to get the optimal separation, which is what the system wants. What we want in the legal system, to have the optimal separation in the guilty and the innocent. Between one that deserves to be 5 years in prison and one that deserves to be 1 week in prison. Yes, we want to make this separation. So that's what the legal system wants to do. Okay? What our result says, what you get in the optimal mechanism and what you get in the equilibria is the same. But since in equilibrium you make deductions from the fact that somebody did not provide evidence, remember the professor who did not provide evidence, you say, well, maybe he didn't have the evidence, maybe it was the guy with the negative evidence, so you are paying the average, you are paying less. Okay? So since in equilibrium you make Bayesian inferences, in the optimal mechanism you should make the same. But the right to remain silent says, no, you cannot make such inferences. From the fact that somebody is silent, you cannot deduce anything. That means it's not an optimal mechanism. Now, there may be very good reasons for the right to remain silent. Of course, it's a big argument, I know. I don't have to tell you guys, yes? It's a big argument, there are many reasons. But that is, from the point of view of separation, it's wrong. Okay? What you really have to do is encourage telling the truth. Okay? This kind of, like in the UK, give a slight boost to the truth. That's good. That goes in the right direction. Okay? Of getting the optimal mechanism. Okay. And I think that that's okay. Just a moment. Wait. Okay. Sorry. Okay. So just to summarize, so evidence games, what are very common setups. I gave you law and economics, there are more. There was medical overtreatment, there are many setups, clearly. Okay? And we have this equivalence between equilibrium and optimal mechanism. Forget this bullet. And we claim that we have identified the right universe where this equivalence holds. Okay? What are the conditions that are needed? Okay? And that's it.
We are short in time, so a couple of minutes for some questions, okay?